Now we will study about writing a chemical equation. Now what is a chemical equation? Chemical equation is nothing but the presentation of any chemical reaction. Right? So first of all, scientists must have experimented. Right? They did some experiments and then they saw that they have to write the equation so that others can also understand, and by the time they can also understand. So they must have realized that before writing it, first of all we have to clear the name of the substances, right? Of course, the chemical substances. So they started denoting some symbols, right? For example, like if carbon is there, what carbon is there, so it is denoted by C. And if hydrogen is there, hydrogen, if we have to denote the hydrogen element, so we will denote it by H. And similarly, nitrogen, it is denoted by N, right? And similarly, oxygen. So oxygen element or the atom of oxygen is denoted as O. Okay. Now they have seen that if we have to denote oxygen gas, so oxygen gas is a diatomic molecule. Diatomic molecule, right? Diatomic molecule means in one molecule of oxygen there will be two atoms, right? So therefore oxygen gas is represented as O2, and similarly nitrogen gas is also a diatomic molecule, so it will be denoted as N2, right? Now this 2 represents the number of atoms in one molecule, so this represents number of atom in one molecule. Okay, and if we have to make carbon dioxide, if we have to denote carbon dioxide, carbon dioxide gas, then it is denoted as CO2, right? Now this is a compound. Why? Because 3 atoms are combined in one molecule of carbon dioxide gas. So that's why this is a compound. Okay. So basically what have we understood? That chemical equation is a symbolic way of presenting any chemical reactions, right? I hope the point is clear. Now for example, let's suppose if we have to write the chemical equation of, let's take an example, like if we have hydrochloric acid, now when it is treated with sodium hydroxide, okay, so then what is formed? Sodium chloride, plus water. Okay, so it has been seen, first of all it has been seen that what happens when a hydrochloric acid is treated with sodium hydroxide. So it has been seen that sodium chloride, which is a salt, and water is formed. Now if we have to mention it symbolically. So what we can write now, hydrochloric acid is denoted as HCl. HCl. And sodium hydroxide is denoted as NaOH. And sodium chloride salt is denoted as NaCl plus. Water is denoted as H2. Right? So before that, hydrogen is denoted as H, and chloric means chlorine is denoted as Cl, and sodium, of course, Na, and hydroxide when OH is written, so that represents hydroxide. And similarly, sodium chloride means NaCl, and water, of course, H2O. Right? Now, when they have started thinking about how to write a chemical equation, so they must have seen that in any chemical reaction, what happens? There will be one substance A, and there will be another substance B, and then the reaction will occur, and some new product C and another one D must be formed. Right? So this is what substance 1, and this is substance 2, and this is product 1, and this is product 2 is formed. Right? Now this LHS side, that is left hand side, this is left hand side, and this one is the right hand side, RHS. What is that? The right hand side. Okay. This is known as reactants. These are known as reactants, and these are known as the products. Products. Okay. It means that if you treat any A substance with any B substance, so what will happen? There will be some chemical reactions and some new products will be formed like C and D. Okay, this point is clear? So, writing any chemical reactions in this format is known as chemical equation. It's very simple. Okay, means you have treated substance A with substance B, and you have got substance C and substance D as the products. Okay, this point is clear? You can note it down, you can pause the video and you can see it, and then you can note it down. Okay? Now the other important points that you need to consider is when you are writing any chemical equation. So first of all, you need to understand that number of atoms of any element must be equal in both sides, means both in LHS and RHS. For example, let's suppose in this chemical reactions, if we see hydrogen, how many hydrogens are there? 1, 2 in LHS. How many hydrogens are here in RHS? 2, right? Means hydrogen atom is balanced. Okay, this is known as balancing the chemical equation. Means, first of all, the reaction must occur. Number one. And number two, if you know that the reaction has occurred, so while writing the chemical equation, you have to balance it. Balancing means, as I have just discussed, balancing means giving the total number of LHS side and RHS side of any atoms must be equal, right? For example, here, if we say that chlorine, let's see how many chlorines are there in RHS, in LHS and RHS both. So in LHS we see one chlorine is there, and in RHS we see one chlorine is there. So it is automatically balanced, right? While if we talk about sodium Na, so for sodium Na, which is only one in left hand side and in RHS side, still it's one, right? So what have we noticed, that hydrogen balanced one in LHS and one in RHS. Similarly, Cl balanced one in LHS and one in RHS. Then Na, sodium, is balanced one in LHS and of course one in RHS. Okay. Now look at here. Hydrogen. Hydrogen is not one. One hydrogen is here in hydrochloric acid and one hydrogen is here in sodium hydroxide, right? So hydrogen balanced, of course, but 2 in LHS and 2 in RHS. Now look at it. H2O. Now H2O can never be written as simple H or simple HO, right? It's wrong. So the formula of water is H2O. Okay. Now oxygen. Oxygen atom is balanced. One in LHS and one in RHS, right? So this reaction is a complete balanced reaction. Are we getting? Right? This point is clear? Means total number of atoms of any element in left hand side must be equal to the total number of the same atoms of that element in RHS side also, right? This point is clear? You can note it down. Now, we will discuss about the types of reactions. Now before discussing about the type of reactions, let's have a quick revision that whatever we have studied. Now we have studied about chemical reactions. How can we understand that some chemical reactions took place, right? So the clear cut understanding is, if we treat any two substances or more than that, right, and something get changed, right, if something is changed means the color, right, the odor means something starts smelling differently, right, and the new product is formed. Or let's suppose some precipitate is there. Precipitate, what is precipitate? Precipitate means insoluble substance in any reactions. Okay.